There we go. Hi, everybody. My name is Justin Richer, and lately I've been doing a lot of thinking about bubbles. Now, the reason for this is that the world that we live in is increasingly mobile, and our connections tend to change as we go through different circumstances. One moment you might be on your phone, and then on a tablet, and then on a laptop, and then moving from an office to a cafe to your home. All of this is flowing around us, and we expect that our identity to be able to work in that type of environment. We don't want to be different people just because we're using our phone versus our laptop, for example, but we want our identities to be flexible enough to live in that space. But our solutions have to work through those contexts as they change. So, for example, I might not get the same type of access in one case versus another, even though I'm the same person. So, to help us think about this a little bit more, let's take this group of people. Now, they've got a set of applications that they want to log into, and this is pretty straightforward for us to solve, right? We can give them the ability to log into all of those applications. But let's face it, what this really means in practice usually is that they end up with different ways to log into every application that they then have to manage, and then it's a mess, and nobody wants that. But thankfully, it's 2024, and we've got a solution for this. We can use an identity provider and federation technology to give everybody a single login and a single account that gets managed to let them actually log into all of their applications. This works really well. It's a pretty well-established pattern, and we know kind of the ins and outs of this. So let's take all this same group of people and their applications, and we're going to put them on a boat. And we very quickly run into the same problem of them needing to log into all of their applications. So we're going to look at the same solution. Why not give them an identity provider on that boat that can let them log into all of those applications, and everything works really well? Except that this is kind of an isolated environment, and these people are probably on that boat for a reason. And so the people who decided to put them on that boat have probably a vested interest in making sure that their accounts are properly controlled and issued and all of this other stuff. So they're going to want to actually take all of those identities, take that identity provider out of the boat and put it somewhere nice and safe, like in a nice big building on land. And this works great because all we need to do is really plug the boat in and it's going to work really well, right? Well, here's the problem. The thing about boats is that they move. And you're going to need a really long extension cable. Now you might be thinking, oh, we'll just do a wireless satellite connection. We'll do radios. This should be okay, right? And that does work for a little bit as you go sailing along. And the latencies start to get kind of a little bit untenable after a certain amount of time until eventually you can't see your IDP anymore. The network is going to like drop, and you're not going to be able to have that kind of connection. And so the federated model in this case, where the IDP is back at this home network and all of the people and all of the applications on this boat, it starts to fall apart because we've got people that are allowed to log in to all of these systems that cannot log in because of the technical limitations. The reason for this is that federated systems are built for this always online, always connected kind of world. And uh, the denied, disrupted, intermittent, and limited or DDIL environment challenges all of those assumptions. So when we're out on the boat, you're not gonna always be able to connect back into those things. Sometimes you'll be able to, but sometimes you won't. It's not it, you're not a completely isolated system, but you're not always connected either. That's a very different type of world. So the type of the simple way to look at this is, well, we'll take our IDP and we'll make shards. So what that means is that we have our IDP back at the building and we're going to declare this is the gold source copy. This is where we keep all of our identities. We're going to keep everything here. And we're just going to make a ton of copies of it. And we're going to give those copies to anybody who needs to in any different type of environment. We've got people on boats, people with drones, people out in, forward deployed disaster recovery scenarios, living out of a tent somewhere for a couple of weeks. And this seems like it'll work pretty well. So now when we do plug in the boat, because sometimes we can do that, we actually download a copy of the IDP with all of those identities, and then we disconnect. And guess what? It works. We're floating out there. We have no connection back to the home system, but everything on board that boat is working really well. And this also gives us another interesting property that when we run into our peers out in the field, well, they've got a copy of the same identity system, right? So all of our policies, all of our, if we want to be able to cross collaborate and connect between these systems, everything should work pretty well because we're all running shards of the same system. It also means that when we go plug back in, we can update any policies that might come down from the home system. Anybody that's not supposed to be on there anymore, we can take care of that. But here's a question for you. I told you that these systems are intermittently connected. So what happens when we run into our peers and we have copies that don't agree with each other? Which of us actually has the gold source copy, right? One of us has got to have the right answer here. So which of us is it? And then this question gets even stranger when you look at a coalition partner, for example. They're going to come in and they've got a copy of their IDP with all of their people, and all of our people are not going to be there, and vice versa. So, how do we collaborate? We want them to be able to connect to us. So, they might have a sailor, and we're like, yeah, bring her on board. We can, we want her to be able to access a handful of things. We know where she comes from. We know we can, all the policies kind of work, but how do we do that connection? Well, we could do it by just connecting to her IDP using existing Federation technologies. That works pretty well, except that her IDP also has a tendency to sail away. And what happens when she can't connect to her IDP anymore? Well, again, the naive thing would be to say, we're going to take a copy of her IDP, load it onto our boat, and now she can log in. This seems to make sense, right? Except that, are we going to do the same thing for our coalition partners? Are we going to go and copy all of our identities into their systems, or are we just expecting them to copy all of their stuff into ours and we get to own everything? There's a huge power imbalance here that is sort of echoed in the technological stack of solutions. There's another problem with this too, is that if we treat this as a shard, well, what really is the state of her account? According to her ship, well, it should be disabled because she's not on board anymore. And they know that she's not on board. So we now have what is effectively a disabled account, according to their view of the world, running around on our system. Shouldn't that be a problem? Well, the truth is, it's not a problem because it's only disabled because she's not there because she's here. So it's enabled for us, and that should be fine. So what's the real way that we deal with this in the real world? We just make her a local account. We tie her into our IDP as a brand new account, and we go sailing along, and everybody's pretty happy with this. This works pretty well. And then we go moving along through the field, and we meet somebody, in this case, who's just having a really bad day. And we decide to pull them up without any existing policy because, well, one, if we didn't, it would go very poorly for them. But two, maybe they'll be useful. This is somebody that we've just met out in the field, and we decide, you know what? You can come join the ship, be part of the crew. We can use you. Maybe you can just even just help the cookout in the galley, something simple, but we want to give you access to some of the applications, some of the systems here in a very limited way because this is a very, very localized decision. So what are we going to do in this case? Well, this person doesn't have an IDP to speak of. They might not have any credentials at all. They're just going to show up and tell us a bunch of stuff. And well, we're going to make them a local account. And if you think that this is a really unrealistic example, I want you guys to think about things like rural search and rescue or disaster recovery. A lot of times, the people that show up are the people that get access to systems by nature of them showing up. This is not something that can be planned for ahead of time because we don't know who is actually going to be there until we're actually out there dealing with the thing. And we don't have the time or ability to go all the way back to the home system to get permission to set all of these up. The other thing that happens when we're out there is that, well, you run into strange things while you're out at sea, and sometimes you need to update certain policies. So we need to mark down a particular account should no longer be used because that person is no longer on the ship, thanks to, in this case, a giant sea otter. Now, in our case, we've got our local IDP. It's connecting all of our applications. It's got all of this great information, and this seems to be working pretty well for us, right? We can talk about people from other domains, people that we just met. Well, what happens when we go connect back into the home system? Most of the time, they're just going to overwrite everything because we now have an aberrant copy of that IDP shard. So what happens to all of that rich information that we gathered while we were out? That's probably still very important and very useful to us. It's not aberrant from the perspective of everybody on board that ship. So the synchronization process is not nearly as simple as it might seem to be out of the box. Additionally, now that we've gone and made a bunch of alterations, who has the gold copy now? Is it the people that have the cleanest copy, or is it the people with the most recently updated copy? This is a really hard question because shards assume that there is a single source of truth. So you always have to answer, if there is a single source, what is it? I think the real question is there a single source of truth? And so maybe it's time that we rethink how we apply federation and even accounts inside of our systems, and not just on boats. So maybe we should think about bubbles. What if we took that entire ship and put it into sort of an enclosed system, and we plug it into the dock and we download all of those sort of pre-provisioned accounts, and then we disconnect and everything works well, and then we can make all of our local all of our local changes. They stay within inside that bubble. And inside that bubble, we've got a really cohesive system. So we still use federation to connect to all of our applications so people aren't managing all these different authenticators and stuff like that. We've still got uh, all of our sort of existing technologies and authenticators. But the important thing here is that we now have a clear boundary around the outside of the bubble. So we have this notion of what goes in and what goes out of the bubble. In other words, we are a data domain, and we have sources for data that we read from, and also receivers that we can send our own data back out to. And we start to look at this world in terms of what goes across those boundaries and how. So when we get provision something from a trusted authority, well, we can write down the fact that it came from a trusted authority. When we plug in at the dock and there's a new account that says you're supposed to be on this boat, and here's your rank, here's your email address, here's your name, everything like that, we write down everything that we need to. And that works really well because even if we have a completely jumbled up copy of the IDP, we may have started with something that was pristine, but we go connect back to the original source. It can say like, "Hey, here's a new thing. Hey, here's an update." We're no longer treating this as just a single copy that now needs the latest version of whatever is up there. We are now copying we are now treating this as sort of an individual domain. And that means that we can make a lot of different copies and replicate this pattern all over the place. And you might be thinking to yourself right now, wait, didn't we just reinvent shards? Did we just give it a different funny name? Well, here's the big difference. That boundary allows us to treat every single bubble that's out there as a unique system, which means we can do things like when we create a new local account, we create it inside that bubble and we mark it as this is something that was created here. When we make changes or modify attributes, those changes happen locally. We don't have to flow everything all the way back up to the master record and have it come all the way back down the tree in order for it to get updated to for our uses. And in fact, I think that this allows us to look at attributes in a different way. So we no longer need to look at this as, oh, we've just got an account and it's got a bunch of attributes and they've got a bunch of values. Well, some of those values actually came from somewhere else. So we might be shadowing them with a local value, or we might be passing through. And the truth is, our source probably got a bunch of those from somewhere else too. And so we can actually start to track the provenance of all of this data as it goes through the system in a really, really sort of continuous path for all of our data that represents all of our users. But importantly, each of these different lines here, they represent a boundary. And at the end of that boundary, inside of our bubble, we have a local identity. And that allows us to have local decisions about everything that happens inside of our environment. So we can do this a bunch of times, and we've got a bunch of individual systems. That means that we have lots of different bubbles. And when we have lots of different bubbles together, we make foam. Now, foam is a really fascinating thing because it's not static. We've got a bunch of bubbles that all sort of move past each other. They connect, they disconnect, and each one of these is unique. So all of these can have different people, different applications, even though many of them may have come from the same source. or parts of the same sources, or a set of the same sources. That means that when we actually go and connect to one of our peers out in the field, there's no longer this question of which of us has the gold source because, well, we both do. We have our own source, they have their own source, and a lot of that is going to come from the same authority. So we can actually compare and do a lot of the same sharing that we did before. We don't lose any of that by treating this as if we are really kind of in our own system. And this also allows us to look at our peers in a different way from coalitions. So when we're connecting to them, we treat them as their own bubble. We might not care necessarily where they got all of their information. We might not have a policy that says we can connect into them ahead of time. But the fact that they are there next to us out in the field, that might be enough for us to be able to make this decision that says, yes, we are talking to you. We are doing this right now because we're here and we're making that decision. So when we bring that person on board from her ship, we write down the fact that, like, yes, she came from this other environment, and the resulting account is a local account. So we federate on the way in to get all of her attributes, to get her history, to get her provenance, and then we associate an authenticator that can be used locally within our system. This gives us a way to build a mutual and limited decentralized trust mechanism where we can start to make decisions based on what's around us in this highly dynamic environment. It also means that this stuff still works when we're disconnected because after we bring her on board, well, the resulting account is local to the bubble. We're not bouncing her out to her IDP every single time. And that's a really important aspect here is that when her account comes in, we know where it came from. We know where all of her attributes came from, but we're not necessarily going back and refetching it all the time. We might actually want to do that from time to time. Like, oh, we haven't seen you we log in within a few weeks, so we're going to go and actually send you back to your IDP before we allow you to go do something else just to make sure this is all refreshed and everything. But we get to decide what level of risk we're actually okay with when we connect out and do that. And then things start to get really fun because, like I said, these systems are not just isolated. They do reconnect. They do actually lock together again at some point in the future. So when we do reconnect, well, we can say, hey, we got this sailor from you, and here's a bunch of stuff that she did. You might want to go look into that. You just FYI, you might want to check that out. Or we can say, hey, we sent you somebody. What did they do? You tell us what they've been up to so that we can deal with them over here, right? But remember the bubbles I said at the beginning, they're not just taking information in, they're sending information out as well. So when we connect out to another bubble, we're sending out assertions, we're sending out credentials and things like that. When we send this provenance package, we can actually say, hey, we got this sailor from the orange system. She's through us right now, and we're telling you that information so that you can make your own trust decision. Maybe you only care that we said she's okay, and that's good enough for you. Or maybe you don't care about us as an interstitial and you want to go all the way back to her host system to make sure that she is the person that she claims to be and where she's coming from. This means that we're looking at traditional federation technologies outside the bubble as a provisioning mechanism and not an authentication mechanism. Within the bubble, we're still using it for authentication and session management and all of this, but going across that boundary, we're looking at this as a way to provision information and synchronize information. This also means that when we connect, we can audit. Because when we go talk back to our auditing authority, we actually have provenance for this person came from here. This person is somebody that we just met and created an account, and that's all we have. And this is extra important because we're going to have multiple roots of trust that we're going to want to talk to. We're going to want to talk back directly to peers. We're going to want to talk to probably multiple different authorities that are auditing different things as we're reconnecting back into the system. At the end of the day, the technology that we need to build all of this isn't new. In fact, we're here today to talk about how we can actually build these building blocks and bring them together. This is just one view of some of the technology that's available today that we can build together using this architectural pattern. Because Federation Bubbles is not a protocol, it's not a product, it's not even really a single system. It's really just a way to think about how we approach identity, especially in these disadvantaged environments. And so, this whole notion of having a boundary in and a boundary out goes a very long way into helping us talk about how we start to pull these different pieces together. I firmly believe that there's not a single protocol stack that's going to solve this. And if anybody, even anybody here on this webinar today, claims that, hey, we're going to sell you everything and this is going to solve it, they're lying to you, because the world is not heterogeneous. Or sorry, it's not homogeneous. It is heterogeneous. And not everybody's going to choose the same protocol stack. I can't tell you the number of times throughout my career where somebody's come along with a magic technology that says, well, okay, this is great and it solves all these problems, and it very well might. But then the next step is now we need to get the entire rest of the world to just agree to use this specific technology, and then it's all going to work. That's never going to happen. Never, ever going to happen. We need to assume that there's heterogeneity in the system and connect based on the bits that we have in common. We might be able to speak a federation protocol, but use different audit protocols. Okay, that's going to be a limitation in some connections. And that's a limitation we need to build around with our assumptions and how these things get deployed. We need to build everything in layers so that we know sort of how we're connecting, connect with standards as much as absolutely possible, and ultimately embrace the diversity that's going to be out there in this world. That's the only way that this is all going to work in such a dynamic environment. We can't predict what all the connections are going to be ahead of time. So in the end, shards, well, they're sharp, they're painful, they kind of shatter, they break things. They're they're not very fun. Bubbles, on the other hand, they're flexible and they're safe. And I think that there's more to the metaphor than just this, right? I really think that this is an important paradigm. So the future that I want to see, the future that I want to build, is a future of bubbles. And at this point, I'm happy if anybody wants to, I'm sure we'll have contact information from the webinar as well. But at this point, I'm happy to turn it over to my fellow panelists and continue this discussion. Thank you all.
Thanks, Justin. I think I'm going to jump in here. This is Justin Chin from Ping. So, when I first started thinking about this topic, it immediately made me go to thinking about the OSI model, right? And how we've always struggled with communication at the different layers, right? If you think about the network layer, once upon a time there was token rings and FTDI and ArcNet, right? And Ethernet, and eventually we standardized, and then maybe even at the application level we had provisioning, right? We had issues with interoperability with provisioning, and SCIM comes along and it's done a really good job of helping us along the way. It's not perfect, but it does a pretty good job. And then of course at the layer that we're talking about, when it comes to communication in general, we had username and passwords once upon a time, and we had tons and tons of those, right? And that's where companies like mine, Ping, came along in 2002, and we've done a good job of trying to simplify that with going federation and making that easy, and trying to hone that in so that folks don't have to remember tons of usernames and passwords. But coming back to the bubble concept, for me, it's sort of the new frontier, because we don't have a way to get in the front door effectively, right? That's what we're really talking about. Like, we have when you're in your bubble, we know how to do it. The OSI model works perfectly. We can communicate, applications communicate, network layer, everyone is communicating fine. Getting in that front door is the challenge. And I think for me, the next frontier represents digital identities, right? If you think about PIV cards and CAC cards, if you think about mobile driver's license on the commercial side, California is doing this now, right? If you go to SFO or LAX, you can use your mobile driver's license to get in. Those are ways to get in the front door. You have some sort of proof that is universally accepted to get in. Now, universally accepted at the bubble that you're going to, right? So for example, I can't take my mobile driver's license and show up to the DOD and they take that as a sub for my CAC card, right? But the point is that there are all these different ways to get in the front door, and that's really the complexity of communication potentially sometimes between these bubbles. And to your point, I think in my mind, ping represents the foam for those bubbles, or the connection between those, the bridge, where we know that there are all these different digital identities potentially get you in the front door, making it easy to get in the front door for that particular bubble. But that bubble has to be able to accept it and know what to do with it. And that's the complexity that, although we have all these standards and protocols, once you're in the bubble that work really well, it's jumping from bubble to bubble, as you kind of expressed with the boat example. And that's where Ping steps in. We try to simplify, we try to make it easy for customers to universally go and get into front door, get in, first time seeing you, without making it overly complex. Now, of course, we have to be secure about it, and we have to, act in such a fashion that we are protecting the contents of the bubble in the bubble, right? That means authentication, that means authorization. That person that we rescued, they have very limited access, right? We the onboarding of them, we allow them on, they can use resources, but it's very limited. That we need to control that, and that's kind of the effect there. But ultimately, the last piece of the puzzle to me, as you mentioned, is that onboarding effect. And that's, I think you're right. We're going to struggle for a long time on having a universal way of doing that. I mean, we look at passports today. Passports is a great example. US has passports. We can accept them universally, but in some scenarios, they are only a way of proving your identity. It may not prove your your authorization. And so again, we have different levels of authentication, authorization, and at the end of the day, we have to make it simple. We have to make it simple for people to jump from one bubble to another. That's kind of where Ping fits in the model, in my mind, for your paradigm. I think there's lots of other layers in there, right? And so Wade, if you wouldn't mind, I'm going to throw it to you for Radiant Logic. Where do you see Radiant Logic fitting in the bubble paradigm?
Thank you, Justin and Justin. Well, I'm sitting here today with SailPoint and CyberArk and Ping, and those are all consumers of identity data. These are engines that need identity information to do their work, whether they're sitting on shore in a traditional model or they're out in the bubble. And I love Justin's model of the bubble because it really does explain the need to be able to take a complete infrastructure and make it independent of the world, but it's reliant on sources of truth to feed that original seed to make that set of data available. But it has to now be flexible enough to accept other sources of identity on the fly from coalition partners, or the ability to spin up a local account that exists solely in that bubble's environment in a way that it can support a user that's brought on board. And as Justin mentioned from Ping, the authorization model is dependent on having as rich a set of information about that user as possible. That may be information they bring with them when they're onboarded into the bubble. It may be information that's generated in the bubble about them based on things we know about them. We can extend that profile. So what Radiant Logic is, it's the repository that provides that infrastructure for bringing information in and out of the bubble, for synchronizing that data. As Justin mentioned earlier, the ability to take that information when you've been out in the field and modified it and present it back to the source, but in multiple different fashions that can be managed and monitored by SailPoint to make sure the policies are properly applied. It can be archived if it needs to as a record of whatever happened in the field. It's not a simple overwrite process. So the ability to be platform agnostic, extensible schema and standards-based gives Radiant the ability to provide that layer of connectivity and flexibility where I can expand the population within my bubble. I can add additional attributes that may come from a coalition partner that I don't have in my system, but is part of the way they operate. I can make this information look the way it needs for CyberArk to do its job. The same identity data can be presented to Ping to do its job, and the same information can be exposed to SailPoint to do its job. And as each of these functions modifies this data, you've got one source of truth in that bubble that you can always point back to, so everyone's using the same information to get the various results that they need. So that's where I think we fit in the model there. James, do you, or is it, no, I think it's actually Frank next.
Yeah. So as we move up that stack of technology within the bubbles, Ping got us there, Radiant stored us there, Now, who defines what we can do and enforce that? And that's going to come from things like CyberArk at the enforcement level, but things like SailPoint at the call it the policy level, right? So we're going to take the trust we've assumed from Ping and maybe a flag that was set in Radiant, and we're going to start building what access should look like and what access does look like. Because as easily as we can get folks into the bubble and we can establish provenance and accuracy and implement the effectiveness of the attributes to grant the access, we also need to be able to remove that person, right? Because the bubble may continue to exist after the user no longer know. So while it's as easy to say as we never sync that person back, but at some point in time, someone may ask us who we let into the bubble. How did they get there? We may have to prove that. We may need to keep bubble A separate from bubble B, or people within bubble A separate from each other. And that's the governance layer, right? And we typically don't think of governance, in the context of military and defense operations in the field, but it's still required. We still need it. As much as we'd like to say, hey, it's a free for all, come crash into my bubble, and now I can go do what I need to do. There's always going to be some enforcement, and we think of that today as things like zero trust, right, and dynamic access assignments, and that just further instantiates the importance of access intelligence. It enforces the need for data insights and all those things that we need to understand about those we're letting in the bubble, those we're keeping in the bubble, in making that decisions to operate with those identities. So, just like you think of your enterprise, whether you're thinking of a financial management system, that mission data that you're protecting is just as critical. And we do need those checks and bounds. James, take it to go a level deeper into the control of the bubble.
Yeah, thanks, Frank, and thanks, Justin. I've been banging the drum for quite some time about the risks to giant sea otters, no matter how cute they are. I'm glad that you brought the sailor eating risk up as well.
The world needs to know.
The world needs to know. Second, we've been talking a lot about people, and Frank just at the end mentioned about data and how we work. And so I want to just talk about real quick and how CyberArk enables. Once we get the people together, we've got to do work. And so I want to live in a bubble world where either the task force commander or the FEMA incident commander can look out and she could say, all right, you two have the best data for now. This third partner, you've got the best application. We need to bring those together. And so what does that mean? We need to bring data and machines, and we need to bring the networks together. And that's why I'm glad you had Spiffy in there. So I'm specifically talking about how Spiffy enables that, again, in an open source model and standard that allows these machines. And I'll talk about that real quick. But the scenario that I like to bring out is, so we need to do that work. And oh, by the way, that incident commander will also say to a fourth partner and say, hey, the application that we have right now is not the one that we really need for this scenario that's now cropped up in front of us. Go and come back in 12 hours and bring back the application that we do need. And oh, by the way, all 5 of my partners are going to need these types of data sets. And again, I think this bubble concept enabled by Spiffy allows that. So, but what is Spiffy? For those who haven't heard that, it's a great new standard. It works by identifying what the workloads are going to be at the process level. So it kind of eliminates some of these other problems. I think that's a whole nother talk in and of itself. But suffice to say that, these workloads are what's critical in a modern infrastructure. And even whether you're in the field, we're bringing clouds to the field, or you've got tactical clouds. We've got clouds that we need to connect right here on land. So that workload needs an identity, and here's, Spiffy can help us out with that. And some of the advantages of going down this framework model, especially around SPIFFE, it's very crypto agile. You could replace keys. You could adopt the environment. It's cloud agnostic, so it's going to work across, orange to blue to green. And it does solve that the zero secret problem. Often, if you're in these environments, in the cloud environment, it's like, how do you seed that first secret and move it out? And CyberArk does have, these types of solutions. We look at the entire identity security spectrum, whether it's the workforce, your IT admins, your DevSecOps folks, and these machines. And we've got solutions to bring to customers to help you solve these types of things I've just talked about. So maybe, Justin, you want to answer that first question, then we have more discussion.
Well, so I actually wanted to, before we get to that, the first thing in the Q&A, I wanted to first thank you guys all for those summaries and point out that nothing that people are talking about here is stuff that was like invented to just solve the bubble problem. At UberEther, we've really been looking at how we can sort of combine existing technologies, looking where the gaps are, and seeing like if we use this in a slightly different way than it was maybe originally thought of, then how does that actually get us into this space? And so, for example, to pick on ping first, it's very clear that you need an IDP and you need account management and all of that stuff inside the bubble, and that's a very traditional type of integrated identity platform. Like, for example, UberEther's IAM Advantage integrated identity platform that uses all of these great technologies as a single integrated system, right? It works really well inside that bubble, but it absolutely falls apart when you hit the edge. And so being able to not only take in a federated identity as like, this is the first time we've seen you, or we're refreshing you, or we're something like that, but also be able to express outbound outside the bubble, that's a very different type of security domain problem than all of your applications in the bubble. So you may end up with two different IDPs that need to be kind of knit together with sort of different data stores, different views, different policies all associated with them in order to be able to figure out how do I connect inbound and outbound throughout this entire system. It's not inventing any new parts, but it's definitely building them in a way that we didn't used to really think about putting them together in order to sort of work in this environment. And the reason that this is important is that if we were just building a completely isolated system, and then this would be easy, right? If we didn't actually have to care about anything else on the outside, we were just dealing with a bunch of local accounts, we can build that all day, every day. That is not particularly an interesting problem to solve, quite frankly. But where it really, really gets fun, if you ask me, is when you're inside that foam, where you're dealing with all these different things, where it's like, okay, so you came from over there and you logged in, and maybe I have this whole flow that allows you to create a local account. Now, what do I do with you? How do I set up the policy that says you're allowed to use these applications? Did you bring an authenticator with you that I've never seen before and I've never vetted? How do I figure out how that fits in here? Like, how do I actually start to tie all of this together? And then when I want to take that same set of information and send that somewhere else, well, that's a whole other set of problems that we need to have cogent answers for. And that's where I really think sort of tying together and building together these different parts in sort of a different way and a different architectural mindset is really, really what it comes down to. And so, you look at the beginning of cloud computing, for example, and the beginning of cloud computing really amounted to people taking things that they used to have a physical machine, and then they had an in-house virtual machine, which was a bunch of basically pretended to be a bunch of physical machines, but they were on just one physical machine. And then they took those physical machines and ran it on somebody else's physical machine, and we called it the cloud. These days, though, we've got containerization, we've got Lambda functions, we've got all of these different bits and pieces and microservices and connections and all of the machine identity stuff that James was just talking about. And we've got a very different way of thinking about what an application is and what it means. I think that we're in a similar space with how we're dealing with human identities and machine identities in these types of environments. We're sort of moving into a place that's not just a local system, and it's not just a cloud system. It's kind of a weird new third space that has aspects of both. And we're actively figuring out what that actually looks like. So thank you all. With that, So Kit's question is bubbles or shards? What is fundamentally different from breaking off these identity silos for local use? You mentioned that authentication locally and yet federate provisioning back to a home IDP, so not sure of the significant change. Um, and really, it's that fact that sometimes we can connect back and sometimes we can't. And so when we have the ability to connect back to get updated attributes or things like that, we want to be able to do that. And when we can't, we still need to be able to authenticate locally. So the real difference is that we are not treating this as just a complete standalone isolated system. We're treating it as an independent system that is then connected in sort of this, sometimes nebulous way out to other spaces in the environment. So sometimes I can see my home IDP, sometimes I can see my peer's IDP, sometimes I can't. And right now, like we don't have a lot of sort of existing policies and patterns for what this kind of thing would look like. So an experiment we did at UberEther about a year or so ago now to prove out some of these early ideas. Um, we took an IDP. Yeah, sorry, Justin, it wasn't ping, but we took an IDP just to see what we could do off the shelf with this thing and like twist it to do stuff. And the immediate thing that it wanted to do was we set up an external account, pointed it at another IDP, and said the user comes from there. And it was like, great. So the next time the user logs in, I'm sending them back to that IDP. I know how to do this. I can just connect. I'm always there. So we had to really kind of twist the onboarding policy to say, all right, first time we get somebody from over there, and then as soon as they log in, prompt them for a WebAuthn credential. Give me your pass key, and then in future, when that person logs in, they say like, yeah, here's my identifier. It doesn't prompt them to go back to their IDP. It prompts them for their pass key. Now, this is a very simple, very small slice of it, but it shows that it's a different way from what systems sort of come configured with out of the box to be able to connect into this. And an important part that's missing that I do think is important to sort of the overall system, that proof of concept that we built didn't have any type of audit capability. It didn't push data back to that home IDP system at all, and we didn't do any sort of later check-in. Like, I'd really like to be able to say, hey, it's been 2 weeks, it's been a month since I've talked to your IDP, but I just pinged them and they're online. So go prove that you still have an account over there. And that may or may not affect the local account because maybe you got kicked off that ship permanently and they're not going to let you back in, but maybe I'm okay with that. And I need to be able to set that type of dynamic policy. And that's where this type of thing that is, the local decision making and, the workflows that a tool like SailPoint can let me sort of have a dynamic workflow that says, in this circumstance, who gets to make the decision of what does this mean? What's the end result? And so it's really important that all of these things come together to sort of build this dynamic space.
So Justin, I just wanted to add, I wish you did use ping, right? So that is the big thing. And I think all of us on this call, all of our individual companies really work hard at being flexible for our customers, right? Because we all know that they're all going to do something different, right? They're all going to have different use cases, and being flexible is important. Like in our orchestration engine, to the exact point that you stated, it's the goal today is to allow junior administrators to be able to configure, right? We don't want rocket scientists to have to be able to do this. And so putting together journeys, putting together these orchestrations of how a user can onboard or how a user can continuously get authenticated, it's important to be flexible and to be able to accept whichever protocol or whichever standard that is coming our way. And so again, from a front door perspective, you should have used the pings to play with.
Yeah, it was a proof of concept. We did do a later proof of concept that did use ping, and don't worry, it failed in other interesting ways. And
I'm
as
sure.
you would expect anything in a proof of concept, I mean, we're figuring out where the edges are here and where the gaps are.
Yep.
But Justin, I'm actually really glad that you brought up the usability aspect of this, because one of the things that we see in a lot of these environments is that the people that are administrating these systems are not necessarily highly trained experts in whatever, identity and security and stuff like that. So I'd like to actually open it up to the other panelists to talk about sort of what you see as enabling sort of a usable configurability in this type of environment, knowing that you're not going to have somebody whose job is dedicated to running an identity server full time.
I could go first. So
Please.
the CyberArk approach, and this is common to, I think, a lot of our solutions. To your point that somebody's not going to have an identity expert, they may not have an education in identity, but how do you configure a vault? How are you going to share machine secrets? And I'll bring it up. We're going to use AI. So we've got a product called Core AI, and that's really a set of AI systems, but it's delivering exactly what you just talked about, is that we want to enable a junior person to say, okay, this is my mission objective, within
Mhm.
this administrative thing. Help me configure the CyberArk tool, depending on what level it is, to achieve that objective. It'll step you through there. It'll ask you, can I do this next step? Can I do this next step? But it's definitely going to guide you to get to your mission objective.
And James, I think that that is a really important point that I know that a lot of technologists that I work with and myself struggle to remember is that the people in these positions are experts. They absolutely are experts, but just not in our toys, right? And so enabling them to get what they need done using the features and systems that we're giving them is hugely, hugely important for this actually working. Because at the end of the day, a messy system that's kind of duct taped together probably gonna work well enough for most people. And going back to the so I've done some work with rural search and rescue teams out in Western United States, the mountains and plains areas and whatnot. And what they tend to do even today is just whoever shows up, and they get handed a sticky note that says, "This is your username and password to get into everything." And at the end of this, we're just gonna delete the hard drive and it goes away, right? So there is no provenance, there is no onboarding, there is no auditing, there is just you showed up, that's good enough, take this and go, right? The thing about that, wildly insecure, absolutely, but functional and usable and resilient in a lot of ways that our traditional sort of like, oh, you're connected to a big data center thinking isn't resilient.
Yeah, but
And
think
that's a
about
really important thing. Please go ahead.
if we had a solution like Bubbles where we wouldn't have to erase that after every incident.
Mhm.
What's the lessons learned in there about how
Mm.
fast we got people, where did they do, how did they do their work, and how we can improve going out of that? So to me, I see that every time you're erasing that hard drive, you're losing valuable information, maybe beneficial later on.
Absolutely. And that goes to what Wade was mentioning earlier about we can't just do just an overwrite. Like we
Mhm.
have to think about this as maybe we archive part of this, maybe we stop shadowing something after a certain amount of time or something like that. So Wade, I don't know if you want to talk more about that piece.
Yeah, you mentioned earlier the question between what's a shard and what's a bubble and how are they different? And I think it really, in my mind, as I started to wrap myself around this, a shard takes on the idea, as you said earlier, that it is a copy of a master, and it wants to go back to the master and be what the master is. So that shard is not built for the changes that come upon it in the world. And as we all know, the one constant out there is change. And like they said, every fight plan is good until someone punches you in the nose. Every mission plan is good until you're in the field. You're going to run into things you didn't anticipate, but you're also going to run into a lot of things you did anticipate that are going to take a level of flexibility. And that ability, I think you said just a minute ago, James, for that information to be retained, to learn from that model, from being able to, you know, the third hurricane you go to, you shouldn't be reinventing hurricane response. You should be building on 2 hurricane responses. You should know a lot more about the people when they show up. This guy can fly helicopters. I already know this because I have him in my system and I retain that data. So having a platform that has that level of flexibility to do that gives you the ability to have a bubble, I think, which is critical. It has to be able to adapt to change in the field, but then not be wiped out when it comes back home. And I think it's critical, again, to apply the policies both from CyberArk and from SailPoint to that return home to say, this is valuable information. You need to recognize it's valuable to the primary and put this in the right place, or enhance this information, or use this, or at least retain it for the next time I go out, give it back to me, even though you don't use it while I'm not here, so I can take it back out in the field. Your other question a minute ago about how do you make this usable, there was a quote someone gave me a while ago, which I thought was kind of interesting. Jet fighters are designed by PhDs. They're built by people with masters. They're flown by people with bachelor's degrees, and they're maintained by people with high school diplomas. And that's the world we create, this massive technology that we give to people who are basically trying to, you know, get by and make sure they don't break anything. So the key from Radiant Logic standpoint is a lot of this can be very similar and sort of blueprinted coming out. So my functions, my processes, the things I do are familiar, and they redo them, and they're not, adapting is not a whole new transformation. It's just an extension of what I do. And that should be mouse driven. It should be visual. It should be something that a low code, no code model. I shouldn't have to ask somebody to write a script or generate some Java code to be able to adapt to the fact that I just had an onboarding event from a coalition partner and I've got 5 new attributes I've never seen before. So the system has to be flexible enough to absorb that unknown shape into the system, assimilate it, without someone having to do a whole redesign of the platform. And change should be something that's non-disruptive in the model. So that's part of what Radiant gives you, is the ability to adapt, to change, to mold as you need to, and it doesn't break things while you're doing it.
Yeah, absolutely. And I think that that notion of being able to sort of learn and adapt these systems, and I like the idea of having some intelligence to help the people do it. Like I'm always, I'm always skeptical of somebody saying like AI is going to solve this problem. I think that that's a not a great way to look at it as a tool. It is, however, a really great way to say like, hey, this is stuff that exists. Give me some inputs and I can push you in the right direction, or I can show you, oh, the question that you asked that you didn't know how to ask, I can show you where to go do that, or help you go do that. And that's where I think that type of thing can be a really, really powerful tool. And yeah, I think we are getting close to the end of time, so I want to make sure with our Carosoft hosts here that we don't run over, because I'm sure this panel could talk for hours about this topic and more.
Yeah, we do have like 4 minutes remaining. If you guys want to close out, then that should be fine.
All right. So did anybody have a final word before we kind of wrap up then?
I just want to sort of build on what you said earlier, is that this is a coalition of some of the best products available in the market, each doing what it does best.
Mm-hmm.
And the better together story is probably really well illustrated in this model, where there are functions that each product is really, really good at doing. And when you bring them all together, the gears mesh and you get a solution that you couldn't do individually. And that's really important, is that much like the idea of zero trust, we're finally telling our customers it's not a product, it's a journey. This is a model, this is a concept, this is a platform that you can build and extend, and each piece can be built out in more and more mature models to make more and more effective use of each of the technologies. But it's a great, better together story. I really like it that way.
Yeah,
absolutely.
Wade, and we've been doing this for a while. Right. This is not something we just invented yesterday. This is stuff that these vendors with UberEther have been doing for several years now. And now we're just, we're calling it bubbles today. Justin, I love the bubbles. Are they champagne bubbles with this group? I think they are. Let's just make sure they're not bubbles in a bathtub.
Mhm.
But anyway, I had to. Sorry. But this is, Wade, again, this type of thing, it's necessary, and so many people don't understand the complexities that go into a solution like this, and where the signals come in to remove someone or add someone or enforce something. And just want to thank you, Justin and Caresoft, for putting this together. It was a great conversation today.
Yeah, thank you all very much. I will say, just to reiterate what Frank was saying, we've been in this tech together for a while. The real change is just how we're looking at where it fits and sort of how the pieces fit together. So, Spiffy as a cross-domain trust source solution, like that's not really what it was meant to do, but it seems to actually fit pretty well in that space. And there's a lot of unknowns that are still being figured out as we push into this space because the models are different. And I'm really, really excited to see not only how existing tools that we have work, but also what new tools we invent and what new sort of combinations we invent as we go pushing out into this exciting new frontier. So thank you all very much for joining today.